Here is our Pyramids, Cones, Spheres version 2 test review. We're going to start with problem number 1, which is a pentagonal base pyramid. Whenever we have a pyramid, we're going to want to look at our base first, which is that pentagon. We also want to make sure we label the parts that we have. So in this problem, we are given the apothem, so the distance from the center to the side length. We're given the true height of the pyramid. We're given a side length, which is here, which is 9. What we're missing is our slant height here. We'll figure that out in just a little bit. But we also need to figure out our base area. All right, so looking at our base area, which is a pentagon. To find the area of the base, we're going to use our triangle right here. And to calculate that area of the triangle, I'm going to do my base 9 times my apothem, or height of the triangle, 6.2, divided by 2. And I can fit 5 of these red triangles in the pentagon, so I'm going to multiply it by 5. When I plug that into my calculator, I get a base area of 139.5. All right, so I'm going to use that in a little bit. The other thing that we want to figure out is the slant height, and this is where we use that right triangle. I can do better than that. And the right triangle, the height is 9. The apothem, the bottom leg, is 6.2. Trying to find this, the slant height. So Pythagorean theorem, I'm going to do 6.2 squared plus 9 squared equals our slant height squared. When we solve that, we will get a slant height of approximately 10.93. All right, so all of these slant heights are 10.93. All right, so now we have all the parts that we need to do our surface area and volume. Surface area. Surface area of a pyramid, you're not given the formula because it is just the lateral area. And when I say lateral area, that is the triangles that go around your pyramid, plus your base area, which we just found. So for this one, how do we find the area of the triangles? Though there are 5 triangles that go around your pyramid, and the base, so if we're looking here, the base of that triangle is the side length 9. The height is the slant height, 10.93. It's a triangle, so divide by 2. We have 5 of those total. And then we add in our base area, which we already found was 139.5. So we're going to go ahead and we're going to calculate that. And we're going to get a surface area of approximately 385.43. And this is surface area, so yards squared. All right, let me do volume next. Here we have volume is this formula for pyramids and cones. So it's 1/3 times, and then B, this part, this is your base area, which we already know, and then H is your true height. So we don't have to do anything other than plug this into our calculator. We're going to take 1/3 of our base area, 139.5, times our true height, which is 9. When we plug that into our calculator, we get about 418.5 yards cubed. So again, when you get a pyramid problem, if it's got a polygon base like a pentagon, you want to make sure you take care of the base first. That includes finding the apothem. You might have to use trig ratios in order to find that missing apothem. Then after that, you figure out your slant height. And then you can move on to using your surface area formula for pyramids, which is lateral area, the triangles, plus the base area. And use your volume formula that works for both pyramids and cones. So let's try another pyramid problem. This is number, let's see, this is number 4 on the review packet. Now this pyramid, you're going to notice, is different than the last one. It has a rectangular base here. And because it has a rectangular base, when we draw our triangles in here to find our slant heights, what we'll notice is we're going to get 2 different triangles, depending on which triangle face you're working with. So with a rectangular base pyramid, most of the work is going to be finding your 2 slant heights. All right, so I'm going to do this blue triangle first. Up here. So let me label sides of the triangle. The height is 8. All right, we need to find the slant height. And the apothem here, this is going to be half of the side parallel to it. So half of 12 is 6. All right, and when I solve this one, so this would be 6 squared plus 8 squared equals slant height squared. When I solve for my slant height, I will get 10. So this slant height is 10. Now let's do the other triangle to find our other slant height. Height is still 10. We're finding the slant height on the hypotenuse. And this time the apothem here is half of this side that it's parallel to. So half of 10 is 5. Pythagorean theorem again, 5 squared plus 8 squared equals slant height squared. Solve for your slant height L, and we get approximately 9.43. So this slant height, 9.43. All right. Now we have enough information, we can start working on that surface area. So surface area of the pyramid, again, is your lateral area plus your base area. Base area will be really easy. We need to focus on the triangles that make up the lateral area. Now, you'll notice we have 2 triangles that are the same, the ones I just traced in red. They have there's 2 of them, they have a base of 10 and a slant height of 10. Okay. We also have 2 triangles here. I'm tracing in purple, this one in the front and this one in the back. I know it gets a little messy, but there are 2 triangles that have a base of 12 and a slant height of 9.43. And then our base area, it's pretty easy. It's just the rectangle 12 times 10. So this is what we're going to solve in order to get our surface area. And when we go through that, these 2 triangles will equal 100. these two triangles are 113.16. The base area is 120. And we add that all up, and we get a total surface area of about 333.16 kilometers squared. Good thing is volume much easier. Again, using this formula, 1/3 times the base area times the height. That's 1/3. The base area was 12 times 10. The height is 8. We're going to go ahead and multiply all that out, and we get a total of 320 kilometers cubed. Okay. So let's move on to our next shape. It would be cones. And for cones, we are going to use these two formulas. All right. So starting with volume on this one. So the volume of a cone is 1/3 times the base area times the height, 1/3 times, and then when we talk about base area of a cone, we're talking about the circle here. So that is pi times radius squared times the height, and we're given the height in this one. So we just need to fill in what we have. That's 1/3 times pi times the radius, which is 2 squared, times the height of 6. By the way, this is problem number 5. And we get a total for the volume of, let's see, this works out to be 4 times 6 is 24, divided by 3, it's 8 pi. And 8 pi is equal to approximately 25.13 kilometers cubed. Surface area. Surface area of a cone is this formula right here. That's pi times the radius times the slant height plus pi r squared. When we're looking at this, we do not know the slant height yet. So we're gonna, whenever we want to find slant height or true height, we're gonna make that right triangle in our shape. In this case, the radius is one of the legs, that's 2. We have the true height, which is 6. Trying to find slant height. So we're going to do 2 squared plus 6 squared equals the slant height squared. And when we solve for our slant height on this problem, we get approximately 6.32. Now that we know the slant height, we can fill in the rest. This is pi times the radius 2 times 6.32 slant height plus. Now we're doing the area of the base, pi r squared. That's pi times 2 squared. And this will equal, when we put it into the calculator, either equals 16.64 pi, which is the same as approximately 52.28 kilometers squared. All right. Our third and final shape from this chapter is the spheres. And for spheres, we're going to be using these formulas right here. All right. So the key part that we need to find for volume and surface area of a sphere is the radius. When we look at our picture, this 4 kilometers goes all the way across through the center. That is your diameter. All right. The radius, which starts at the center and goes to the edge of the sphere, is just half of that. So our radius is just 2. So now that we know the radius, the rest of this is pretty easy. Volume formula, 4/3 pi times the radius cubed. So in this one, it's 4/3 times pi times 2 cubed. All right. This is problem 6B on the review, by the way. And let's see. The volume here is going to equal 32/3 pi kilometers cubed. I'll let you plug that into the calculator if you want the answer to the hundredths place. Surface area, just as easy since we know radius. Surface area is 4 pi r squared. So 4 pi times 2 squared. And in this one, 4 times 4, that's 16. So we have 16 pi kilometers squared. All right. So those should be pretty easy. Find your radius, then plug them into your volume and surface area of spheres formulas. Our final problem I want to go over is a composite shapes problem. And with the composite shapes problem, we're going to start with surface area. And what we want to do is just think about what are the surface areas that we need to get the total surface area. So when I look at this, I notice right here, this part, this is a hemisphere. Okay, so if I'm thinking about how do I find just the surface area of that hemisphere? Well, surface area of a sphere is 4 pi r squared. So the surface area of a hemisphere, which is half of a sphere, is going to be the same formula, just cut in half, divided by 2. And this would simplify to just 2 pi r squared. Okay. So that is the top of my composite shape. The bottom of my composite shape is a cone. So how do I find the surface area of a cone? Surface area of a cone is this formula, pi rl plus pi r squared. When I look at this formula, this pi rl is the lateral area. So that is this part. And we need that part because that's the bottom part of our composite shape. And pi r squared is the base of our cone. Excuse me. The base of the cone is here, inside my composite shape. I do not need this part. I'm going to get rid of this. Surface area is the outside of your shape that wraps around it. So our total surface area is going to be the hemisphere, 2 pi r squared, plus just the lateral area of our cone here. And it looks like we have most of the information. We got the 2 and the pi. We have the radius of the hemisphere is 5.1 squared plus pi times the radius 5.1 for the cone. But we don't know slant height. So same thing as before. We're missing slant height. We're going to make our right triangle. We know the radius is 5.1. We know the true height of the cone is 12.2. All right. And when we solve our Pythagorean theorem here, this would be 5.1 squared plus 12.2 squared equals the slant height squared. We would find that the slant height is approximately 13.22. So that's what I'm going to put here in my surface area formula. So my total surface area, when we plug it into the calculator, is going to be approximately 375.24 feet squared. All right. So again, before you start solving, figure out what are the surfaces or faces that you need to add together to get the outside of your composite shape. Let's go to volume now. So here, volume is a little bit easier. Volume is going to be the hemisphere plus the cone. So let me do volume of the hemisphere first. Volume of the hemisphere is this formula here, and it's a hemisphere, so we're going to take half of that. So that means 4/3 pi r cubed divided by 2. The volume of the hemisphere, that's 4/3 times pi times radius 5.1 cubed divided by 2. When you plug that into your calculator, for the hemisphere, you get approximately 277.82. Then we want to find our volume of our cone. The volume of the cone is, again, that generic formula, 1/3 times the base area times the height. The base, now we're going to use this base, and that is pi r squared. So that's pi times 5.1 squared times our true height, 12.2. And that volume, when we put in the calculator, we get approximately 332.3. Total volume, just add these two together, right? Because we're just sticking the hemisphere on top of the cone. So our total volume in this problem, just adding the two volumes together, and we get a total of 610.12 feet cubed. All right, so that concludes our Pyramid Cone Spheres version 2 test review. Answer key for the rest of the problems is posted on Google Classroom for you to review. Good luck on the test.